Good evening. Welcome back to the atomic structure. This thing we have seen the Bohr model and the principal quantum number, that is the n, and principal quantum number where r equal to n square a0, that is the radius from the nucleus to the orbital. Then we have seen the energy of the orbital, that is E equal to minus RH by 1 by n square. From that each orbital energy also you can see as per the Bohr from electron, whenever it is absorbing energy or from lower state to higher state it is going, and absorption spectra will get, or from higher state to lower state if it is coming back, emission spectrum you will get. So it's very good. So then now comes to the problems in the Bohr model. Bohr model could not explain about the why molecules are forming, why atoms are combining and forming molecules. That is one this thing. And it could not tell about the Zeeman effect, that is the nothing but the spectrum under the influence of magnetic field, and the spectrum under the influence of electric field, that is Stark effect. And it is not able to explain the dual of the spectrum lines and all. Why? The reason is we'll see the afterwards. Then we have already seen the de Broglie wave nature for the light. That means light is having the particle nature as well as the wave nature. That is the de Broglie's this thing. Now the question arises this whether can we take this de Broglie dual nature to the photon we have already taken, which is nothing but the speed of the light whenever the particle is traveling. Can we take to the electron? Yes. It is applicable to the electron also. Whereas, what is the limit? Up to the point of the milligram level, the particles, macroscopic particles, yes, limit is up to 1 microgram. More than the particle size, if it is there, it cannot be applicable, and it should travel with the speed of the light and all these things. So this dual nature of the de Broglie theory has to be extended to electron also, which was not considered by Bohr. Then one more thing is okay, dual nature is not considered. Then one more theory has come, that is dual nature. This thing is nothing but lambda equal to h by mv. Mv is nothing but moment, mass into velocity, that is momentum. That is p, lambda. Then comes to the Heisenberg concentricity principle. The Heisenberg concentricity principle, Heisenberg has told that exactly you cannot locate the position of the electron and the velocity at a time. If you are able to tell the velocity, you cannot tell the position. If you are tell exactly, and if you are telling about the position, you cannot tell the velocity. Both cannot be. So in the mathematical form, delta x into delta v equal to h by 4 pi m. That is the mathematical form. This is the uncertainty. From this, what is the conclusion of the Heisenberg, or what is the importance of Heisenberg? So electron is not now traveling along the fixed line, that means orbit all. What Bohr has told exactly. It is this you cannot find out actually. So then a probability theory has come, most probable location has come. Then the Heisenberg and Schrödinger has derived some of the equations. The Schrödinger equation is most popular. That derivation and all these things are not there. But on solving the Schrödinger equation for the hydrogen atom and all, we have received some solutions, that is the quantum numbers we have received. So one other failure for the Bohr model is that it has not considered the dual nature of the particle electron, and it has not considered that Heisenberg uncertainty principle also. That means Heisenberg uncertainty principle is not considered. Because of the reason Bohr is not able to explain the other than the hydrogen atom, and even hydrogen atom also small problems. And another one is the electron. For electron also this dual nature is applicable. Fine. Now coming back to again atomic model to the Schrodinger equation. Schrodinger has proposed that there will be some, after solving the equations of the for the hydrogen atom Schrodinger equation along with Heisenberg, then there are 4 quantum numbers he has proposed. Of course, spin quantum resonance not much. Now we will see only the other 3 quantum numbers, that is principal quantum number. And now no longer this Bohr model of orbital is valid. Now orbitals is having some other meaning. So first he has proposed the principal quantum number. Principal quantum number is represented by n equal to as a positive integer 1, 2, 3, 4, and it represents shells. Shells is KLMN. That means K when K we are talking. That means n equal to 1. That is K. N equal to 2. The KL n then 3m. There is 4 is n, like that. What actually the principal quantum number importance and why it is required? It gives the, anyway radius you will come to know, and you will come to know the energy levels and the okay. So by knowing the radius, that means you will come to know the size. So you will come to know the radius from the nucleus, how far the electron is. So from that the outermost electron, from that you will come to know the radius. Then from that means it is the size of the atom you will come to know. That is one. And shape also you will come to know. Shape also, right? Then one more thing you will come to know from the n is the orientation. So from the principal quantum number you will come to know the shape, size, shape, orientation. That n equal to 1, 2, 3, 4, and the shells if you are talking K element shells and all, right? Then electron will be revolving around the nucleus in the most probable areas only we can find out and all. Then azimuthal quantum number, then second one is the L. It gives you about the orbital angular momentum of subsidiary quantum numbers, and L is nothing but n minus 1. That means when n equal to 1, K shell L equal to 0. N equal to 2, L equal to 0 and 1. That means it starts from 0 and ends with n minus 1. So like that, if it is going on some 4, n equal to 4 means 0, 1, 2, 3. There are 4. So these are the subcells. So subcells is again represented by the notation 0, 1, 2, 3. The value for L equal to this one, and subcells notation is SPDF. Till means almost all we can cover in those electrons, atomic numbers and all in this only. So up to the SPDF we can see. So we'll see the magnetic quantum number, and then some other small shapes and other things, because orientation also is most important. That means what is P, what is S, what is D, what is F, how it will be filled, and what is the orientation and all. We'll see. Thank you.